All right, so I'll be sure to keep this pretty short. I want to move on to the real interesting part. But just to give an overview, here at Mesosphere, what we see going on with our customers and our open source users, and a little bit of trends. So everybody knows this quote, right? Software is, all companies today really need to be software businesses. We're really facing a fundamental shift in how companies are engaging with their customers. So if you look at the 2000s, even still going on today, a lot of companies were experimenting and trying to deploy things like Hadoop, and really build these big data warehouses. And a lot of companies faced a lot of challenges with doing this. There was a recent Gartner survey that said something like 50% of Hadoop deployments actually failed. And today, really successful companies are going beyond big data to what we have been calling fast data. So fast data is really using streaming data coming in real time from customers to then provide real-time services to those customers. Some examples, things like autonomous cars, connected devices, connected homes, things like that. So I always like visual examples. This is a photo from Vatican City in 2005 during the announcement of the Pope. You can see there's one guy there in the corner. He's holding up his flip phone. Maybe he's making a call to his mom or something. So what's interesting is not that photo, but how it compares to this photo. So this is from 2013, same event. And what we see here is not everybody just that they have smartphones, but they have these connected devices, they have endpoints, and they have expectations for services being delivered to them on those endpoints. So companies today really need to be able to meet the needs of this type of a customer and these types of users. So just to give a few examples of some companies kind of leading the charge in terms of these data-driven modern applications. One is GE. So they're building an industrial IoT platform to optimize asset management and also operations. So they're basically doing machine intelligence and data analytics from a cloud data center and also to machines that are at the edge. Audi is another example. So Audi is delivering a traffic light information system that actually helps drivers better navigate cities. Yelp is another one. A lot of people know what Yelp's doing, but Yelp is crowdsourcing reviews of local businesses. And actually, Yelp runs millions of tests every day, and because of Mesos, they're able to push code to production, very, very quickly, and in hours and minutes instead of days. And the last tier is 2 Sigma. 2 Sigma is a hedge fund that's based in New York, and they're using machine learning to basically build new algorithms to predict the future of financial markets. So modern enterprise apps, like I showed on the previous slide, can handle the large amount of data and the large amount of users because of 2 things. One is containerization, and the second is big data services. And these are made possible by platform services. So platform services fall into these 2 areas. Container orchestration, which basically coordinates how containerized microservices get deployed and run on a cluster. And then data services, which basically capture, store, process the data that's created by those containerized microservices. So in the last few years, continuing every day, we just see this huge explosion of the number of data stores and analytics engines. So as a developer, as a data engineer, you're looking at all these options, and it can be overwhelming. But it's also exciting because there's so many options for how to build these fast data applications. So how do you choose, right? Or how do you know which is most popular? This is a visual of basically, a fast data application needs some basic functionality along each of these lines. So the first is, events come in through connected devices, whether that's a car, a wearable, your phone. And then you need to ensure that data is captured with, no loss, and you have to be able to, take in millions of events per second. Analytics, so you need to be able to, analyze data to gain new insights, whether that's streaming or batch, machine learning. And then you need to be able to store that data. It needs to be highly available. So, data is coming in, you're analyzing it quickly, you can't lose any of that data. It also needs to be scalable to meet the needs of, having huge numbers of users. And then finally, you need to be able to present insights to a human, or you need to either trigger a reaction in a connected device or application. So the SMAC stack is really, a key set of technologies that has emerged as the most common way to build these fast data applications. So I'll just go through each of these quickly at a high level, but you're going to learn way more than I could ever teach you in these 30 seconds. So the first is Kafka. So Kafka is a distributed, highly available messaging system. It was created at LinkedIn, and today it's used in something like over 100 plus web scale companies. Very popular. Next is Spark. So Spark is a large-scale data processing engine. It does micro-batching, which makes it very fast. And it supports different things like SQL and machine learning and graph computation. Next is Cassandra. So Cassandra is a distributed, highly available database. It's an Apache project that was born at Facebook. And then Akka is a toolkit and runtime to simplify the development of these data-driven apps. And then finally, Mesos. So Mesos is a cluster resource manager. It's a platform essentially to run and deploy data services in containers. Mesos has this concept of a two-level scheduler. So Mesos itself is relatively simple. It basically aggregates resources. And then it allows basically each of these applications on top, or data services, to have specific scheduling logic baked in that actually takes into account the capabilities and factors of the application. So this is just a summary of why you'd want to build and run your streaming and fast data applications with a SMAC stack. So it's essentially an integrated set of data services that allows you to ingest, analyze, and store streaming data. Simple deployment and operations to get your apps to market faster. It's highly available because of the Mesos underpinning, so you don't miss any customer interactions. And then finally, because of Mesos, which essentially pools the resources in your data center or cloud, it allows you to run at very high utilization and save money on cloud and data center costs. Okay, and since you're at Mesosphere, I'm going to give you the 5-second overview of Mesosphere. So, Mesosphere's focus here is really to make running Mesos as simple as possible. So we have an open source project called DCOS that essentially allows you to pool and run containers, data services, and basically allows you to operate or automate the operations of those data services. So you can do things like one-click deployment of data services, automated upgrades, updates with rollback, things like monitoring metrics, manage persistent storage volumes. So essentially, we're trying to make Mesos and the data services that run on Mesos as easy as possible. Just a quick snapshot. This is what we call the DCOS universe. It's essentially an app repository for packages for things like Spark, Kafka, Cassandra. So we have both open source and then partner supported. So Confluent and DataStax, Lightbend, for instance. All right, and then I'll end there. So that's it. I'll hand it back over to Corbin and your speakers for tonight.